Well, hello and welcome. I wanted to walk you through some of the procedure for the Galactic Center Lab that we're doing, and so show you kind of the steps there. The first thing it asks you to do is to look at the listing of globular clusters and to find the average of their X values and their Y values. So I've just reproduced part of the chart right here, and so what we want to do on that is we want to take all of these values in the X column. There's 25 of them, add them up and divide by 25. Like it says, you may want to do that once or twice just to double check your work there because it's a lot of numbers to add up. And then also add up the numbers in the Y value column and divide those by 25. Once you do that, you'll get the average X value and the average Y value. And when you've done that, there's places in the data sheet to write that. I'm going to just make up a couple of numbers to do some work with. So just kind of show you the process. You won't get these numbers, but let's just say that when you did all that arithmetic and added up all those things and divided them, that you got 1.92 kiloparsecs. This will work here. 1.92 kiloparsecs for the average X value and negative 2.60 for the average Y value. Then from there, we want to calculate the distance to the galactic center, treating that as the two sides of a triangle, a right triangle that get us to the galactic center. That's where the formula that looks like the Pythagorean theorem that comes from. So to find the distance to the galactic center, I'll take the square root of my X value, which is 1.92 kiloparsecs, sorry, 1.92 kiloparsecs squared. I'll leave off the units here just for the time being. And then negative 2.60 kiloparsecs squared. And when we square those, for the first one, we get 3.686 and some other decimals after that that I'm not going to write down. And for the negative 2.6, it's 6.760. And notice that we're squaring the minus sign as well. So that squares to a positive. So it's plus 6.760. Add those together, and it would be the square root of 10.446, which is equal to 3.23. And that would be kiloparsecs. So again, if these were the average X and Y values, then we would have found the distance to the galactic center of 3.23 thousand parsecs, 6.23 kiloparsecs. Now, then along with that, you're going to plot the X and Y positions of each one of these globular clusters on the chart that I've got reproduced here. And I've gone ahead and plot the first three values here. So let's look and see where I got those three dots from. So the first one, NGC 3808, has an X value of 2.3 and a Y value of negative 8.8. And so on that one, I go to over 2, slightly more than 2. Then I go down to negative 8.8, which is just short of 9, and I put a dot right there. So that's the first globular cluster. Then for the next one, it is negative 3.8 in the X and negative 7.9 in the Y. So negative 3.8 is almost a 4. So go over there, back 3.8 down to 7.8, and right there is where I put a dot for the second one. Then for the third one, 3.72 to the right and 6.7 down. So over 3.7 down 6.7 and put a dot right there. So you continue doing that for all 25 of the different globular clusters. And then also it asks you to put a dot or a mark for the galactic center, the X and Y values of the galactic center. And use a different shape or different color on that just so you can tell that that one's not one of the globular clusters. So I'm going to do the 1.92, in this case to the right, and down 2.60 for that. And so let's see, so I'm going to use a different color here, and I'll use a little bit bigger dot here. So I'm going to go over again 1.92 and down 2.6. So 1.9 would be right about there, and down 2.6 would be right about there. So somewhere right about there would be the mark I'd put for the galactic center as I calculated. Again, those are just made up numbers. You'll get a different average when you actually find the average of all those X and Y's. And that is basically the graphing and stuff. And then the one final part you want to do is to see where that actually is on the sky. So when you get the average in X and Y values, you want to look back at your chart and find the cluster that has the X and Y values that are closest to that, right? And so in my case, again, with these made up numbers, it looks like the only one that's close to 1.9 is 47 tuc, 47 tucany, as that's an abbreviation for it. And then the negative 2.6 is pretty close. So I would say that that is the one that is closest right there. Right. And so I'm going to write that in for the name of my closest cluster. Again, yours is probably going to be different because I'm just making up numbers. And I want to write down what the galactic longitude and latitude are for that one, which is the first and second column. So it is at 306 degrees longitude and negative 45 degrees latitude. So I'll copy that down and just copy it down off the chart for that particular one. And then the last sort of procedural thing is to look at the chart that's in the write-up for the lab that tells you what constellations are on what galactic longitude, and find the constellation that's closest to 306. And if I look on that, that's right at the value for the constellation Crux. So I don't have that part of the data sheet listed. But if we had this value for the position of the galactic center, then we'd have this globular cluster, which is near the constellation Crux. And so that would be telling us that the center of the galaxy is toward the constellation Crux. That's not true. Again, those are just made up numbers. You'll get a more actual realistic result when you do it yourself. All right, as always, let me know if you have questions, and hope that you have a good time doing this.